I hope you all are doing great. My name is Anjali and I am a senior software developer at Microsoft working in their Windows team. I am an educator at Relevel. So today we have a problem that is minimum coins to make a sequence. So I assume you must have solved some questions on coins already. If not, then probably this could be the first one. Alright, so let's move to the problem statement and it is saying you are given two arrays A and B. You can insert any integer, any number of times. In array B, you can insert the integer at any position. Each insertion cost is going to be one coin. You need to find out the minimum coins required to modify array B such that array A becomes exactly same as B. So, what is actually given to us in this question. So, basically, like just forget about the logic or everything. But what is the given thing? That is arrays. So, you must be knowing what arrays are going to do. Arrays are a linear data structure and it is going to get stored at a contiguous memory location. Means every elements are going to get stored at one position. And when we talk about arrays, so in this one, how we can actually access the element in this one accessing the element is going to be easier when we are going to access it just by their index. So that is the best part about arrays. Now what they are saying, two arrays are going to have some different set of values in that. Now they are saying you can insert any integer any number of times in array B. So you will have to insert some values in array B, and when you are doing that, you will have to see like whenever you are inserting, that is going to take a cost of one coin, and also you need to see that what is the minimum coin which you require when you are modifying the array, like you are actually making the array B. Uh, sorry, you are actually making the array A becoming equal to the array B, and when you are going to do that, you are going to have two operations. One is deleting the elements which you do not require and inserting the elements which is actually going to make our work easier. So these are the two things which you are going to do. So in this one, they are also providing us a note that is array A contains pairwise distinct elements, means it is going to have pairwise distinct elements in it, whereas B may or may not have duplicates. So for B, we do not actually have any condition, but A is going to have a condition. All right. And then they have given some constraints like what NA is. NA is the number of elements in the array A. What NB is number of elements in array B. And then they are providing other constraints as well. So what I will do, I'll take you to the OneNote and there we are going to solve it. All right. So we'll utilize this place for the same. So first of all, you should be knowing that what and all things are there. So you are going to have some cost, and in this particular one, they gave the cost as one coin. So we can say that we have two arrays. We have array A. I'll make it white only. So we have array A and we have array B. Now, since elements are going to be different, so let us say the number of elements in array A is NA. Alright. And for the array B, we are saying number of elements in array B is NB. That is how they are providing the count. Why are we not taking one variable here? Because not necessary that in the beginning they are going to have similar set of elements. All right, later on we are going to make it exactly same, but in the beginning that is the condition which is not given to us. All right, apart from this, what is the another thing which is given to us? So now like basically we are actually discussing the given parameters for this question. Okay. After this, they are also saying that we are going to have a cost associated with the insertion. So we can say we have another parameter C, and that C is going to have the cost for insertion of element. And how we are actually going to define this cost, we are going to define it in terms of coin, like one coin for one insertion. So here we do not have any unit, like we have the currency in terms of INR, dollars, euros, anything. Here we are just going to say it is going to cost you one coin. So that is how you will actually have to proceed ahead. Also, they are saying that A is going to have distinct elements, whereas for B may or may not have distinct elements. So that is also one of the condition. So now if we will like understand from the problem statement, so what is given to us? They are providing us a condition with the operations which we can perform here on our array. So I will write down the operations which we can perform on our array A. So operations which can be performed, you can actually have two operations. One is going to be removal. Why we are removing? Now, if you remember what the question was saying, you have to make it exactly same. So let us say in array A, you have some of the elements which array B is not going to have. So first of all, what you will have to do, just get rid of those elements. So that is how we are going to come up with the operation. That is going to be remove any element from the array which is from the array A, which is not there in array B. All right. Now I'll take you to the problem statement. What that was saying, it said for the insertion, it is going to cost you one coin, but for the deletion, they are not giving you any condition. So when we will be solving it, in this case, removal, no cost involved. Okay, so you can remove as many elements as you want to in order to make it exactly equal. All right. Now, what is the second operation which is going to be available for us? That is insert a new element anywhere with cost, with given cost, we can say. So let us say after removal of the elements, I'll be taking some examples so as to explain it to you. But for now, if you will have to understand that what we are doing, so after removal, obviously there may or may not be a condition where you will have to add any element. And when you are adding any element, that every addition, every insertion is going to cost you one coin. So that is how this one is going to work. So this cost is going to be determined by the C integer which we have taken. All right. Now I'll take one example and I will show you how it is going to work. So let us say we have array A as 1, 6, 3, 5, and 10. These are the set of values which we have. And array B is going to be 3, 1, 5. All right. And I am saying C is going to be 2 coins. So even though the question is saying one coin, but how I'm going to write this program, I'll write it in a way that you can provide any value for the cost and it is going to work in the correct order. All right. Because we always have to make our code generic. Generic means something which you can actually run it for any set of inputs. All right. Also, it's like the generic scope is not just limited to this. We have a vast scope. Let's not get into that for now. So now if you will see for the arrays A and B, if you will see for the array A, how many number of elements do we have? Total we have 5 elements. And for the array B, how many elements do we have? We have 3 elements. Now we will have to see what and all elements are going to be there. And also one more thing which we will have to take care, that is when you are making array A exactly similar to B. So you need to understand one more thing, that is going to be it needs to be in the same order. So now if you will see actually at the array A, so what and all values do we have? 1, 6, 3, 5, 10. I'll explain it to you what I'm saying. Then B is having 3, 1, 5. So if you will actually go ahead with that okay, just get rid of the numbers which we do not have in array B. So that is going to be 6 and 10 because 1, 3 and 5 we already have here. But it is saying that it needs to be there in the same order. So accordingly, if 1 is here, if we are going to pick this 1, in such a case, you have to insert 3 here and then you will have to get rid of 3. I do not know if I'm actually able to ease it out or not. So I'll actually write it down at the bottom. So that is 1, 3, 6, 5, 10. Okay, I'll show you the different answers available for the same. And we want to make it equal to 315. This is your B and this is your A. So one way is you get rid of 6. You get rid of 10 because these are the two elements which are not here. But if we want it in the same order, in such a case, you will have to actually get rid of 3. Then what you will be doing, what you are left with 1 and 5 after removal of all the values. Then what we will have to do, we will have to insert 3 because we want to make it exactly same. So then it is going to become 315. So this is one of the approach. So in this particular one, what we have done, we actually got rid of 6, 3 and 5. Sorry, 6, 3 and 10. So these ones we removed and then we inserted 3. And this one became exactly similar to A. That was your given array. Alright, so this was one of the approach. Now I'll show you another approach. That is like we have in A, we have 1, 6, 3, 5, 10. And your B is going to be 3, 1, 5. That is how we have the two elements. Alright. Now in order to make it exactly same, what we will have to do, one way is remove 1, 6 and 10. So this we removed, sorry, this we removed, this we removed. Now we are left with 3 and 5. Since you can insert the value at any position, that insertion is not going to make a difference. So what we will do, now we can say you insert 1 between 3 and 5. So when you are inserting this, what you are going to get, you will get 315. And now this is exactly similar to array B. And this is what was actually intended. So now if we will actually see what is the cost which got involved here, this involved one insertion. And every insertion, it costed 2. So total cost is going to be 1 into 2. That means total cost is 2 for this one. Now, if we will come here, again, what we did here, we did one insertion. Per insertion, it costed 2. So total cost is going to be same. So either of the ways you can pick, and in both of the ways, you are going to get the same solution. All right, I'll take another example so as to explain it better. If you didn't get, if the, with this example, if it is still a doubt for you, okay. So another example is going to be, so let us say we have A as 10, 5, 2, 4, 10, 5, and we have B as 5, 1, 2, 10, 4. Like this, we have two array available, all right. And in this particular one, they are saying C is going to be 3, means every insertion is going to cost you 3 coins. Okay, So in this particular one, what we will be doing, we are going to like again, can have different approaches. What I will be doing from this array A, I'll just write down the values 2, 4, 10, 5. In order to remove the values, if you will see, we have 5 and then 1, 2. So what I can do, I can get rid of 10. I can actually insert 1 here to make it equal to that, right? And then if you will see, after 10, it has 4. But here we have 4 here. So you can actually get rid of 4. You can get rid of this 5 here. Again, multiple solutions can be possible, okay? So if you are removing, so remove 10, 4 and 5. So what you will be getting? You will be getting 5, 4 and 10. So if you will see, we got in this one, we got 5, we got 2, we got 10. But we need 1 and we need 4 here. Correct? So what we will be doing? We are going to insert 1 between 5 and 2. Alright, so what we will be getting out of it? We will be getting 5, 1, 2, 10. Now if you will compare it with B, so we even got 1. Now just 4 is there. So what we will be doing? Insert 4 at the end. So after that, what you will be getting? It is going to become 5, 1, 2, 10 and 4. And I was saying you can actually do it in any approach. So what the other one could be, I'll actually take you through that as well. So let us say your A was 10, 5, 2, 4, 10 and 5. And your B was 5, 1, 2, 10 and 4. So what you can do in the previous one, we deleted 10, 4 and 5. So in this one, we'll try to delete any other number so as to show you the different transition. So here let us delete 10 and let us delete another 10 and 5. I'm just showing you the different approaches for this problem. Okay. So what we are doing here, remove 10, 10, 5. So what you are getting, you will get 5, 2, 4. Now if you will see in this one, you got 5, you got 2, you got 4. You need to have 1 and 10. So what you can do, you can have one insertion that is going to insert 1 between 5 and 2. So what you will be getting, you will get 5, 1, 2, 4. Then you will see, okay, now it is actually becoming somewhat close to the given solution. Now if you will see 10 is there. So you can insert 10 between 2 and 4. You can actually have different approaches as well for the same, but you will have to pick the one which is giving you the minimum cost. Okay, so now this you can actually get the given array. I'll actually show you one approach. With the help of that, you will actually get maximum cost. Okay, so let us say we have some same example. I will be taking 10, 5, 2, 4, 10, 5. Okay, just up to 5, and B was 5, 1, 2, 10, and 4. In this one, what you can do, one approach can be like, just I'm coming up with the possibilities. Okay, so in one go, what you can do, remove all elements. All right, then what you can do, insert 5. So you now you just have 5. Then you can do insert 1. Then you will have 5, 1. Then you can do insert 2. I'm not saying this is the efficient approach, I'm just showing you that this can also be there. If you have doubts that can we do it in this way, yes, this is also there. So then after 5, 1, 2, what element we have? 10. So it is going to become 5, 1, 2, 10. And after that we have 4. So just to insert 4. So you will be getting 5, 1, 2, 10 and 4. Now let's evaluate the cost in all the three approaches which we have done. So in this particular one, what we did, We removed elements, zero cost. Then we inserted one element. So this is going to have like plus C, I'm doing that. It is going to add some cost. And here also we are adding another element, so 2. So how many total cost is going to happen? Number of insertions multiplied by cost. So total 2 insertions we have done. Every insertion was of 3 coins. So total we spent 6 coins in this. If we will look in the another one, so here also we did 2 insertions. So total cost is going to be total number of insertions multiplied by the cost of one insertion. So that is how you are going to get value 6. But if you will look at the last approach, what we are doing here, removing all elements, this is going to be 0. Then one insertion, two insertion, three insertion, four insertion, five insertion. So total how many insertions we are doing? 5. So total cost is going to be 5 multiplied the cost per insertion. So through this, if you will see, it involved 15 coins. So is it going to be the efficient approach in order to solve it? Answer is going to be no. So depend like even though the question is can actually have various solutions, but which one do you have to pick? The one which is involving minimum cost. So either of the two approaches for this example you can actually pick and you can come up with the solution for the same. Now what I will do, I'll discuss the naive approach for the same and then we will move into the efficient one. So what is the naive approach in this one? That is saying that is like a naive approach. We always refer to that as either brute force or the easiest solution. Okay. So that is the one which is saying you remove all the elements from the array A which are not present in the uh, array B. Okay. So I'll actually write it down so that you can actually relate with everything. So in this, erase all elements in array A which are not there in array B. So it is saying you just get rid of all those elements because we do not require them. Okay. After this, what you will have to do? After this, you will have to generate all the combinations. So what it can be? So let us say you have, I'll be going through it with the help of an example. So if let us say we have 10, 5, 2, 4, 10 and 5. And let us say your B was 5, 1, 2, 10 and 4. So it is saying get rid of all those elements which are not there in array B. Order doesn't matter, okay? For now, you just have to get rid of the elements. So 10 is there, okay? So we can keep either of the 10. Then next element is going to be 5. Or let's do one thing since the problem statement was saying um, you have to consider all the distinct elements, right? So let us take this one. Okay. Now since 10 is there, I'll have to add another element. 5, 2, 4. Well, let us say we have this as 15 and we have, oh, that one we can keep as distinct. So let us say we have elements like this. So it is saying what you will have to do, get rid of the elements in array A, which is not there in array B. So if you will look here, we have 10 here, which is available in array B. So this one we will be keeping. Then we have 15. So do we have 15 in array B? No. So get rid of it. Then I'll actually delete some of the elements so that we can actually do some insertion as well. All right. Now we will look at 2. So do we have 2 there? Yes. So we are going to keep 2. Next one we have 14. So do we have 14 there? No. So get rid of 14. Next one we have 5. So do we have 5 there? Yes. So we will be keeping 5. Next is 6. So do we have 6 there? No. So we will be getting rid of it. So according to the step 1, now the refined array A is going to have just 10, 2 and 5. After this, what it is saying, you like after this, what you will have to do, you will have to make the all the permutations of this one in such a case that it is going to become equal to this, and then you do the insertion. So if we will have to look at that sequence, so what and all we can do, we can actually convert it like this: 5, 2 and 10. So like these are the permutations which you will have to form. And after this, what okay, in between this we need element 1. In between this we need element, like after this we need element 4. So that is how it is going to become exactly equal to B. So in this one, what we are actually doing, we are generating all the possible permutations. So this says generate all permutations of the remaining elements in the array, and for each sequence, because like again our major constraint is to find out the minimum cost, right? So it is saying for the each sequence you will have to actually check for the minimum cost. If that sequence is giving you the minimum cost, you can go ahead with it. But what if it is not giving you the minimum cost? In such a case, you will have to get, like you will actually have to move to the another sequence. Okay. And so and for each sequence, check for minimum cost such that array A becomes same as array B. All right, that is how you will have to do. Now, how you can actually generate the permutation. So I'll not go into depth about it, but I'll give you one overview. So for generating the permutations, you can have any approach. And even if you're just going it, so what the meaning of permutation is. So I'll give you a brief overview about permutation. So what permutation means, let us say this actually checks for all the possible combinations for the given condition. And let us say we have a number 5. For that one, if I want to check the permutation, this is how I am going to denote it. Like this factorial is actually telling me that I am checking for this, like I'm actually going to check for all the possible combinations. So how it is going to be 5, 4, 3, 2, 1, correct? And how permutation is going to be happen. So let us say we have to create a three digit number from these ones. Okay. And uh, condition is that if you are picking any number at this place, at the another one, it should not come. So for the first one, how many options do we have? 5. For the another, how many options do we left with? 4. Then we will have 3 and so on. So that is how it is going to be there, right? So if you want to find out the permutation, similar way, like even if you're finding it out for any other thing, similar way you will have to make the choices that where and all you are going to place the element. And if you are placing the element, how the other elements are going to get affected. And like just come back to the topic. So if you want to find out the permutations, how you can do, one of the approaches using the heaps algorithm. But what actually happen in the heaps algorithm, in such a case, you actually end up taking up a lot of memory. And in this one, like what is the time complexity for the permutation? So it is going to be order of n factorial. All right. And you can actually use heaps algorithm to find out permutations. But here, if we will have to look at our naive approach, so what is the overall complexity for that is going to be? So you are going to have a loop which is going to run from 0 to number of elements in A. Then you will have another loop which is going to run from 0 to number of elements in array B. And after that, what you will be doing, you are going to use some permutation code here, correct? If you want to find out the overall time complexity for this approach. So let us say this is n. This is m. Like instead of nb, I'm taking n and m. Okay. And for the permutation, let us say we have n factorial. So what is the overall complexity? So the overall complexity is going to be n into m into n factorial. Can you imagine how big this time complexity is going to be? It is going to be a lot. Now, what we will be doing, we are going to use some other approach, and that approach is going to help us in providing some efficient solution. Okay. And in this one, what is our, like, if you will actually go through the problem statement one more time, I'll open it. Yeah. So it is actually asking you that you have to make that sequence, like actually when you are trying to make one array equal to the another one, what can actually be the possibility there? The possibility can be you are having some common sequence. So what you can do, you can find out the longest common subsequence, because here also, like whatever the approaches which we have discussed, so what and all things are we doing there? We are getting rid of the elements in A which are not available in B. So obviously we are left with some common sequence. So it is saying, first of all, you find out the common sequence and then you move ahead. So like I'll actually take you there step by step. So what it is saying, you have to use LCS here. What is LCS is? That is longest common subsequence. There is a separate problem here on this. I'll not go into detail. I'll just keep it restricted to the given problem. Okay. So what we will be doing in this, what usually happen, they will provide us some sequence. Okay. From those, like they are going to provide us some two sequence, and from those we will have to find out the longest common subsequence in both of the cases. And when we are finding out the longest common subsequence in such a case, we are not going to go on its order. What does it mean? So let us say I have some sequence like A, B, C, D, E, F, G. So out of that, if I have to tell you the common subsequences out of this, like just for the example purpose, it can be ABC, it can be ACD, it can be AFG, it can be DEF, it can be ABDFG, anything. So if you will see, not necessary, the two elements are going to be there together, but if you will have to tell the longest common subsequence, so these are not this, we have many others. So by this, you can actually understand that for a given string, you can have various subsequences available. And again, you have to go through this topic in order to understand about the longest common subsequence. Now I'll come back to the problem which we were having. And in that one, what we can do if we want to optimize our solution. So we are going to use LCS there, okay? And that is the efficient solution. So efficient solution. So in this one, why we are using the efficient solution? Because we just saw how big the time complexity was coming when we were using the naive approach. In this one, what we will be doing, we are going to find out, like first thing is going to be find out length of the longest common subsequence. So what it is going to do, if you have two values available to you, and if you are getting rid of, if you are able to find out the longest common subsequence, now you know that okay, This is something which I know. Now, what is going to be the next approach? You have to find out the elements which are not yet there here. How you can find out? So let us say, like I'll give you very small example for now. So let us say we have some values like in array A, 3, 2, 4, 1, 5. In array B, we just have, let us say 5 to 4. These are the elements which we have. So it is saying, first of all, you find out the length of longest common subsequence. So in this case, what is going to be the LCS length? That is going to be 5 to 4, right? Like this is the common thing which you will have to find out. So you can say you found out, and let us say we have 6 here. So you can say your LCS length is 3. Now what you know, in order to make this array similar to the array B, you know you already have a common stuff with you with length 3. Now what do you want here? Since length is 4, you know you just have to insert one element, and how you are finding it out? So number of elements in B minus LCS length. If you are doing this and later on, if you will multiply it with the cost value, you can easily get the total cost. Correct? Just find out the total number of elements in B array, then you find out the LCS, and once you have both of the things together, what you will have to do? Just multiply it with the given cost. So that way you are going to get the total cost which you are going to use. And I'll actually write it down in the proper form. So you can actually say cost is going to be equal to, like I still like I'm just using NB here, and then you are going to do LCS on which you are doing your array A and array B, and then you will be multiplying it with the cost factor C. So that is how you will be doing. This is the LCS for your arrays A and B. This is going to be the cost factor, and this is going to be the number of elements. Okay, I'll actually write down. So number of elements in array B. This is going to be the longest common subsequence in A and B, and cost per insertion. All right, that is how you can actually find out your total cost. Now I will be telling you some steps, and when we are going to move into its implementation, we are going to go through these steps. Okay. So these are the steps, like what I usually do early, if you have a problem which actually involves a lot of things. So you know what is the good approach to solve it? Just wrote down the steps which you feel you will be actually doing, and then like this is nothing but building your algorithm. So first you build your algorithm and then you move into implementation. All right. So in this one, what you will be doing, first of all, you create a new array. All right. And let us say we are going to name it as index. Okay. After this, what you will have to do, whatever values you have in this index, you have to initialize it with some value. Okay. And then initialize it. Then you will be creating another array. Let us say we are creating another array as nums. So this why we are creating it. So you will be actually understanding, since you know for LCS, we need to actually store some values, right? That is how you are going to store that, okay? We till this point, the values are matching, and that is how you are able to come up with the LCS, right? So for that one, we are actually taking use of these indexes, these arrays. Then you create another array. So let us say you are creating some nums array. All right. After this, what you will have to do, you have to map all the elements of array B to its corresponding index in the array index. So what we are basically doing in order to find out the common sequence, first of all, your array B is actually going to be something which is playing the major part. So what we are doing here, first of all, we are mapping with all the values. So let us say initially, like let us say we are initializing everything to -1. If any value is matching, what we will be doing, we are just going to update it. Otherwise, it is going to remain -1. So when you are going to traverse all your array, you can see, okay, if -1 is coming, that means this value is not available there. If something is there, that means its value is going to get updated. So that is how we will be actually seeing how the values are actually going to come into the picture. Okay. So third one is going to be map each element of the array B to its corresponding. You know why I'm writing all these things? Because after this, when we will move to the code, it will be literally very easy for you to actually map your code with these statements. And you can later also, you can just understand it to a better depth. So we are going to map it with the corresponding index in the array index. Okay, after this, what you will have to do, you have to traverse the given array A. Why are we doing it with A? Because through this, we just accessed all the elements of B. Now we want to map all the elements of B with A. So for that one, we will have to traverse our array. So what you will be doing, you traverse the given array and you insert the values with the mapped values. All right. That is what we will have to do. So if you have any value available, how you can figure it out? Like initially, let us say we are initializing it to -1. So later on, if the value is -1, means this element is not available. But if that value is something else, that means we will understand it is actually mapped with value in array B, right? Now, what you will have to do, we have already written point 4. So point 5 is going to be, now you find LCS of the array nums. So you are going to have this array and LCS, we are going to find it out here. And what we are going to obtain from this array, we are going to obtain length of LCS, means the common longest common subsequence between both of the arrays. After finding it out, what you will have to do, whatever formula we have discussed, just use the formula to calculate the total cost. All right. If you are following all these steps, you are actually going to understand it to a good depth. I am reducing the view. And now what we will do, we are going to move towards our code. And through that, you will be actually understanding that how we are finding it out. So what we will be doing, I'll be writing down its code in JavaScript and on Visual Studio Code. I'll get rid of the old code. Yeah, so first of all, what do we want to do? We want to create arrays, right? So I'll take array A and let us say I am providing the values like 1, 3, 1, 6, 3, 5 and 10. The first example which we have taken. Then I will be defining another array B and that one is going to have the values that is 3, 1, 5. After this, we need to define some cost as well, right? So for the cost, what we will be doing, we are going to define it a value, let us say 2 there. All right, now we need to find out the length of array A and B. So what we will be doing, we are going to take const Let us say I am doing it with MNet. Okay, like anything you can do. So it is going to be a dot length, and then you will be defining n. N is going to be b dot length. After this, we are going to create a function that is going to be minimum cost, and to this, what and all we are going to provide? A, B, your M, your N, and C. So this is all we are going to provide to that function. So we are going to build it step by step. So first of all, I wrote down whatever things which are available to us. Now what we will be doing, we are going to create our minimum cost function. To this, whatever parameters are there, I will be writing it down there, and I'm using arrow function in order to create it. All right, you can use even the other approach, but this is something which I always prefer. Now, what I told you in this, we said we are going to create new array that could be index, right? And then we will have to initialize it. So what we will be doing, we are going to create one array. So let us say we are creating let index. Okay, and then let us say we are creating the array of size, a big size I am taking, because in this particular one at least we know what the size is going to be, but we do not know for the other one, since here we are hard coding the values, right? And I am actually doing fill. So what fill is going to do, so this one is going to change the values, right? And it is going to fill the parameter. So let us say I want to fill it with 0. Similarly, what was the next step? That was create another array nums. So similarly, I will be creating another array nums. Now what do I have to do? I have to initialize array index I with value -1. So what I will be doing for the same, I will be taking a loop starting from 0 till this length, and then for every value I will be providing -1. Like you can actually do it in another approach as well, but this is the one which I am following. So here we are initializing it to -1. Initialize index array with -1. And what this index and array is going to do, so your nums array is actually a auxiliary array. So this is how it is going to act. All right, and what this index is going to do, so this one is going to store the position of the elements of array A. So stores the positions of elements of A, because we will have to actually perform a mapping of the values. So after this, what we will be doing after doing all the initialization, we need to update the array index. That is what the next statement was there. You have to map to its corresponding index. So that means you have to update the array index, right? So what we will